So we're going to see how tangent lines are used in practice and also how to find them. So let me set up the entire problem here and you can see. Take two. We're going to see how to find the equation of a tangent line. We're going to see how to find both its slope, which is that's the part involving a limit, and also how to find the exact equation of the line. So the problem here is to find an equation of the line that's tangent to the graph of y equals x squared, where x equals 2. So in other words, what we want to do is find the equation of the line that you see in thick purple here. So first of all, what we noticed is that since the function is y equals x squared, that's the blue parabola that you see here, when x equals 2, the point on that parabola is going to be 2 comma 2 squared, or we can just write it in. That's going to be 2, 4. I'm going to keep it in the form 2 squared when I do this problem, just so that you can see the mechanics of how we do this. So based on the discussion from the previous screen, what you can see is that what we want to do is write an equation for the secant line that goes through the point where x equals 2 and the point where x equals 2 plus h. Here, h is just some arbitrary number that represents the distance between 2 points. So what you can see is that I have just this interval here, and I've given it the distance h. What we're going to do, of course, is we're going to let h drop to 0 so that we can take the limit as h drops to 0. So what I want to do is, first of all, I want to find the slope of this tangent line. And the way we're going to do that is we're going to say that what we're going to call m tan for m tangent, is equal to, first let's write the expression for the slope of the secant line. That's going to be, we can see that the 2 points here, the two y values are 2 plus h and, point to those a little better, 2 plus h squared and 2 squared. So this is going to be 2 plus h, and let me write this a little closer, a little further away. This is going to be 2 plus h squared minus 2 squared. That's the two y values subtracted, and then on the bottom we're going to have 2 plus h minus 2. So in other words, I'm subtracting. Recall that the slope formula is y2 minus y1 over x2 minus x1. That's what I'm doing here, is I'm just subtracting y values on the top, x values on the bottom. But what we want to do is we want to find this as the distance between the 2 points drops to 0. So I'm going to take the limit of that expression as h approaches 0. So now I'm just going to simplify this limit. This is going to be equal to the limit as h approaches 0 of, let's expand each of these terms. So 2 plus h squared is 4 plus 4h plus h squared. And then 2 squared is itself 4. And now I'm just going to simplify the bottom. 2 plus h minus 2, the 2's are going to cancel, just giving me h like that. So now let's do a little simplification here further. This is still going to be the limit as h approaches 0 of, we got 4, let's see, 4 plus, well actually I don't need to do that step. We'll do 4 plus 4h plus h squared minus 4. So that gives us 4h plus h squared over h. And another step here, we can write, that's going to be 4h over h is 4, and then h squared over h is h. So if the limit as h approaches 0 of 4 plus h, we can easily solve this by substitution. That's just going to be 4 plus 0, and that equals 4. So that is the slope of the tangent line. Well, once we have the slope of the tangent line and we have a point on the line, we can easily write the equation. So I'm just going to write the equation of tangent. And I just want to be very clear about what I'm doing. I found the slope of this tangent line using the method that we described in the last slide. And we have the point of tangency, which is 2, 4. That's where the line grazes. That's where the tangent line grazes the curve. So the equation of the tangent using point-slope form is simply going to be y minus 4 equals 4x minus 2. And we reviewed point-slope form in an earlier video on pre-calc, and this is one of the reasons that it's important for this course. So there's the answer. That's an equation of the tangent line to the graph y equals x squared. So note, there are really two different techniques that are in this problem. One is using the limit as h approaches 0 of f of x plus h minus f of x over h to find the slope of the tangent, and 2, using point slope form to find the equation of the line. Sorry, I know I wrote that a little sloppy. Hopefully you're listening to the narration. So this is how you do that sort of problem. So what I want to focus on for the next couple of examples is going to be how you would evaluate, how you would set up and evaluate this limit in a slightly more complicated context. Before we go on, I just want to give you some notation for the derivative of f of x at x equals a. So we use this notation. We write f prime. That's what this symbol means. This is the prime symbol. So to refer to the derivative of the function f at x equals a, we write f prime of a. We also sometimes use this notation. We write df over dx, and then put the notation x equals a, or sometimes with an at sign, x equals a. Or if we've defined that y is a function of x, where we've said y equals f of x, we might write dy over dx equals, sorry, dy over dx with, again, the notation x equals a. These three things all mean the same thing. They all mean the derivative of f at x equals a. And just to be clear, the we have here is the value of f prime of a, or any of these other symbols, is a number. I just want to be clear on that. It's a number. It's the slope of the tangent to the graph of y equals f of x at the point a comma f of a. The reason I'm being so emphatic about this is that I know that many of you have taken sort of a high school calculus class, or even the AP class in calculus, and I want to be absolutely clear about rigorously what we mean. The Many of you have already skipped ahead mentally and said, wait, I know all about derivatives. I know that there's this thing where I take the exponent, I bring it down, I reduce the exponent by 1. We'll get to that, okay? And those of you who haven't taken the class and don't know what I'm talking about, you can skip over this right now. The point is that I want to be clear that this is what the derivative is defined to mean. There are ways that we're going to find it, but it is defined as the limit that I gave in the first slide and in the last two examples, and what it means is specifically a number that gives the slope of the tangent line. The operation I just described involving exponents and the function x, and the functions of x, we will talk about that later. But for now, just understand f prime of a, where a is some specific constant, is a number that gives the slope of a very specific tangent line. So just for example, in the previous example, what we did is we used the function f of x equals x squared, and we found the tangent, or the slope of the tangent line to y equals f of x at the value x equals 2. We found specifically that the slope of that tangent line was the number 4. So what we would write is that f prime of 2 equals 4. That is a correct statement. We could also write it in this way or this way. All of those would be correct statements.